Lesson 3.5, Arithmetic and Geometric Sequences. The essential question is, how do you identify a sequence as arithmetic or geometric? We have two new vocabulary words. The first one, arithmetic sequence, or you may hear some people say arithmetic sequence, is a sequence with an addition or subtraction pattern. So that means the same number being added or subtracted over and over from one term to the next. It has to be the exact same number being added each time or being subtracted each time. If it changes even once, it's not an arithmetic sequence. A geometric sequence then is a sequence with a multiplication or division pattern. So just like with the arithmetic sequence, it would have to be the same number multiplied or divided over and over. It can't change even once. Okay, it's very important that you write these examples in your notes. It says find the next three terms in each sequence and then determine if the sequence is arithmetic, geometric, or neither. Because if it doesn't have a pattern involving the same number being added, subtracted, multiplied, or divided over and over, then it's neither. It can still be a sequence, it can still be a pattern, it just isn't arithmetic or geometric. So, the first sequence that we have, 2, 4, 6, 8, this one should look pretty familiar to everyone. What's happening on this sequence is it's going up 2. So 2 is being added each time, which would mean the next three terms are 10, 12, and 14. And because it's a pattern with addition, repeated addition of the number 2, it's an arithmetic sequence. So I'll just use a capital A for that. The next example, you could check to see if it's an addition pattern. To go from -3 to -9, they would be subtracting 6. But to go from the number -9 to -27, they're subtracting 18. So that tells me that it is not an arithmetic sequence. So I need to think about multiplying or dividing next. If I multiply -3 times +3, I get -9. If I multiply -9 times +3, I get -27. So I need to continue that pattern. So if I multiply by +3 again, I'll get 7 times 3 is 21, carry the 2, 3 times 2 is 6, plus 2 is 8, so -81. Then I multiply by 3 again, I get -243, and multiply by 3 again, that would be 9, 4 times 3 is 12, carry the 1, so -729. And that would be a geometric sequence because it was a multiplication pattern. Okay, my next one. I'll check for addition first. If I add 4, add 4, add 4, perfect. So continue adding 4, 17, 21, 25, another arithmetic sequence. The next one, when the signs are flipping back and forth, negative, positive, negative, I know it can't be an arithmetic sequence. So, multiplying. If I multiply -5 by -2, I will get +10. Multiply 10 by -2, I get -20. So that means the next one, multiply by -2, goes back to positive 40, then -80, and then +160. geometric. Whenever the signs go back and forth between positive and negative, it's usually what you should check is to see if it's multiplied by a negative number or divided by a negative number. All right, the next set of numbers. 1, 4, 9, 16. They're all positive, so I'm going to check and see if it's arithmetic. Add 3, add 5, so it's not arithmetic. Add 7. Okay, it's not arithmetic. Could it be geometric? 1 times 4 is 4. 4 times 4, though, would be 16, not 9. So it's not arithmetic or geometric. It's going to be neither. I do see a pattern, though, so I can certainly use my pattern to find the next 3 numbers in this sequence, because it went up by 3, then 5, then 7. My thinking is it's going to go up by 9. That would be 25. Then it's going to go up by 11, which is 36, and then 13, which is 49. You may recognize that this set of numbers, these are perfect squares. They are perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. So they are a special type of numbers. They just don't make an arithmetic or a geometric sequence. Okay, our last example. All negative numbers, and I see a pattern because they're all odd numbers. So what's happening is they're going down 2 more. They're further away from 0. So it's 2 that's being subtracted each time. So negative 11, negative 13, negative 15. So that is arithmetic, another arithmetic sequence. On this next slide, we have a click and drag activity, and we haven't talked about the rules, the general formulas yet, so I'm going to click and drag those 2 first because I would do this for my class. So an arithmetic sequence is f of x equals mx plus b, it's linear, and then our geometric sequence, it's actually ab to the x power. We just can't format the exponent here, so it's supposed to be that the x is up higher like that. And the geometric sequences create nonlinear or exponential graphs, so they're curved, where arithmetic sequences create lines. Now looking down at the bottom, there are 8 sequences down here, so I'm going to look at them and see if I can determine what kind they are. This first one that I'm moving is going up 6 each time, so it's arithmetic. The next one I'm going to do, this one is, if I click on the dots, it scrolls for me. So this one is times 10 each time, so it's geometric. This one is just going up 2 each time, so it's arithmetic. This one's going up 8 each time, and I can click to make sure. This one is multiplied by 3. This one's adding 11. This one's multiplied by 2. This one is subtracting 10. This one is multiplied by negative 5. This one is divided by 2, or multiplied by 1/2. This one is divided, let's see, I better scroll it. This one is divided by negative, let's see, is this one wrong? This one is supposed to be divided by negative 2. It's just missing a comma after the 12. This one is subtracting 3. This one is subtracting 5. And this one is multiplied by 3. Okay, now if I click the check button, it shows me that all of those are correct. You're now ready to write your summary. And your homework is a worksheet.